Okay, so section 2, all about similarity. Here we go. What does it mean to be similar to something? Well, similar polygons just mean that you have two shapes that all the corresponding sides are proportional to each other, and all the corresponding angles are going to be congruent. Okay, so the best example, I'm going to use triangles here, just because that's what we're going to be using most often. We can look at these two triangles, ABC and DEF. And if we start making proportions with these sides, you can see that the 6 is going to line up with 3, the 8 is going to line up with the 4, and the 10 is going to line up with the 5. So you can come up with this proportion. 6 is to 3, as 8 is to 4, as 10 is to 5. And you can see all of those reduce to 2 to 1. Okay, and I didn't mark it in here, but I could. These angles are also congruent. So I could say that, angle C is congruent to angle F. Oops, and then angle A. Here we go, congruent to angle D. It's been a long time since I've done this, so sorry. Angle B congruent to angle E. You get the idea. Oh, that was terrible. Oh well. Okay, so that's what it means for similar polygons. Their sides are going to be proportional. That means every ratio that you come up with for every single pair of corresponding sides has to reduce down to the same ratio. And all of the corresponding angles have to be congruent. Okay, so Theorem 61 says that the ratio of the perimeters of two similar polygons is going to equal the ratio of any pair of corresponding sides. And let me tell you, if you can remember this theorem, this will save you a bunch of calculations that you might end up trying to do, save you a lot of time in the future. So if we were to actually just, go through and figure out the perimeter for each of these triangles, triangle ABC, you can add up all three of those sides, and triangle DEF, you can add up all of those sides, and we can see that we get 24 to 12, which reduces to 2 to 1. And if you go back up here, this was a ratio of a pair of corresponding sides, 6 to 3, that also reduces to 2 to 1. So you can see how that would work out. So what that means is you don't actually have to add up all the sides here and all the sides there to make your ratio. You can just look at a pair of corresponding sides and say, oh, 10 to 5, that must be 2 to 1. And sometimes that's the only way you're going to be able to do it because you don't know some of the sides of your polygon, so you wouldn't actually be able to add them up. Okay, so keep that in mind. Okay, so let's do a problem. What kind of problems are you going to have to do? Well, mainly these are computational problems where they're going to give you some polygon and they'll give you the sides of one polygon, and maybe they'll have a few sides missing from the other polygon, and they'll tell you that the two polygons are similar. Oh, by the way, in case we haven't mentioned this right here, that is your symbol for similarity. So it looks like your congruency symbol without the equal sign underneath it. Okay, so they told us that triangle ABC is similar to triangle DEF. And it's really important to look at the order of your letters because the letters should match up. So the angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. What that also tells us is that segment AB, because those two are first, corresponds to segment DE, right? Well, this is going to be really important when they start giving us our diagrams where the figures are all upside down and mixed up, and you're not going to be able to see naturally that 3 goes with 2, or that 5 goes with DF, or 8 goes with EF. You'll actually have to read the letters to figure it out. Okay, so what are we going to do in order to solve this problem? We need to figure out what DF and EF are. So I'm just going to label those with variables, x and y, to make it easier for us. And then I'm going to come up with a proportion. So let's do the first proportion in order to solve for x. Well, I know x matches up with 5, and then I know that 2 matches up with 3. So I can come up with a proportion 3 is to 2 as 5 is to x. And some of you out there are probably saying, or maybe you already set up your proportion and it's a little different. Maybe you did 3 is to 5 as 2 is to x. And that's totally fine. You can do that as long as you are consistent. So you did 3 to 5, so you started here and then did the long one. You have to start here and then do the long one. But by the means extremes ratio theorem, it means that everybody can come up with a different proportion, but when you cross multiply, you end up getting the same thing. So hopefully you guys, no matter what way you wrote your proportion, you ended up getting 10 over 3. And if you didn't, then you set up your proportion wrong. Okay, so let's try it again to solve for y. So y is going to match up with 8, but we already have this 3 and 2, so we're going to use that same ratio. 3 is to 2, and since I started with 3 on the top, I have to start with 8 on the top, so 8 is to y. So 3 is to 2 is 8 is to y. Once again, maybe you did 3 is to 8, and so now you're doing 2 is to y. Or maybe you started with the y to 8, and then 2 to 3. Lots of variations, as you'll see. Okay, so we cross multiply and we solve and we get y equals 16 over 3. So I think this is some pretty basic algebra. I think you guys should be okay with this. The real hard part is going to be to make sure that you are setting up your proportion correctly, looking at the letters to make sure that they line up and you know which segments go with their corresponding counterpart, I guess. Okay, that's it for now. Ta-ta!